Good morning, everyone. So last time we have learned about the type checking. We have seen what is type checking and what are the types of the typecasting and etc. So today we are going to study static versus dynamic type checking. Type checking can be of two types, static versus dynamic, right? So we'll see the difference, static, and we'll see what is dynamic. So the first difference that we can see is the static type checking is done at compile time, right? Compile time. That means when you are compiling the program, the static checking will be done that time only. But the dynamic checking is done at the runtime. At the runtime, which means when you will compile the program, it won't show any error, but when you will run the program, it can show the error, right? So the second difference can be all the properties, all the checks can be verified before program runs. In the static checking, right? But in case of dynamic checking, it permits programmer to be less concerned. What is the meaning of that? About types, which means you just design the program as a programmer, and whatever error will be there in the form of type checks will be handled at the runtime. You need not to concern at the time of designing of the program. If you can handle, fine. If you can't handle, then it can be handled at the runtime, right? So in a static, the program will not be executed if there is any type error in case of a static, right? But in case of dynamic, there can be warnings or no comments at compile time, which means how will you know that there is an error? You can only identify if your program is going to run and you are finding some logical error or your program is generating some exceptions, right? So what is the advantage of static type checking? It is desirable when fast execution is important. Execution will be fast. Why? Because there will not be any error. You have solved all the errors at the time of designing only. And what is the advantage of this dynamic checking? It is very clear and flexible. It gives the flexibility to the programmer that he can design the program, and after that, when the program will be executed, the problems can be identified, right? So this is all about the static and dynamic checking. Now let's see one example of static and dynamic checking. The one disadvantage of the static checking is it restricts the programmer. If you're designing a program and you don't want to apply any kind of checks, the compiler won't allow you to run the program till you won't handle all the errors of related with the type checking, right? But there are certain cases where static type checking cannot be done. It can be done only at the time of at the time of execution. So we see one example. For example, there is a loop uh, I less than 10 and I plus plus. This is the loop you have applied. And before this loop, we have an array of say 5 elements, integer array of 5 elements. Inside the loop, what we have written, ai equals to 10, right? Now, the loop should give the error. The loop should give the error, but in the statistical type checking, in the static type checking, it won't give error. Why? Because ai, the value of I, will be assigned at the time of execution. It cannot be assigned at the time of compilation. So this error will be identified at the time of execution only. So this is a dynamic type checking. You cannot apply in this logic static type checking, right? So there are certain cases that one of the case we have discussed right now, in which we cannot apply static type checking. The type checking can be only handled at the time of execution only, right? Now see what can be the static type checking. Say, if I'm trying to store 100 at 10th index and it is not present in the array actually, because the array is having only 5 index, 0 to 4. So in this case, static type checking will be applied. This is static type checking. And this is dynamic checking. Right. This is static checking. This is dynamic checking. So while designing the compiler, the developer should not be very hard that your compiler will always check type errors at the time of compilation only. I mean, there should be flexibility given by the developer so that the checks can be handled in the dynamic time, as well as in the some checks can be handled in the static time also. That is compile time also, right? So next topic is type expression. So first of all, what is type expression? As the name suggests, it is an expression of types. It is an expression of types, right? So first point, it is used to represent types of language constructs. It is used to represent the type of language constructs. And second, type expression can be of 3 types. Type expression can be of, first, it can be basic type. Now, what is the meaning of basic type? The type can be integer, the type can be character, the type can be float, etc. These are the basic types, right? These types are also called as atomic types. What is the meaning of atomic type? The type which cannot be segregated further, which cannot be divided further. Like if you are declaring integer a, so there is only one value which can be stored into a. It cannot store multiple values. So these type of data types, these type of types are called as atomic type, right? Which cannot be further divided. So if I ask you that can you define that string is a basic type of or not? We'll discuss this question at the end of the lecture. So you think that whether we can define a string in the category of basic type of not, or we can keep a string in the category of basic type or not, right? Now there is one more thing that is called as type error. Type error. It is also comes under the category of basic type. What is the meaning of that? When the type cannot be identified by the compiler, cannot be identified by the compiler. Now let's take one example. Take one example. Suppose I have declared integer x and z, and I'm writing the expression that x is equal to y plus z. Now, can you tell me what type of error it is going to give? Y is not defined. So this type of error also comes under the category of basic type error, right? Now the second thing which comes under the category of type expression is type name. What is it? If type name can be defined with some other name. This type of checks comes under the category of type name type expression. Now let's take one example. In C language, in C, I'm giving you this example. Suppose we are using type def. Type def command is used to give the another name to the data type, right? Whether it is a user defined or it is a primitive data type. So I'm defining ABC name to the integer data type. Now, after that in a program, I have written ABC and I've declared an identifier X for that. And I've declared Y as the integer. Now the question is that, can your compiler identify where X is equal to Y or not? Now there are two things. If your compiler is handling name equivalence type check, then these two data types are not similar because the name of this data type is different and the name of this data type is different. But if your compiler is handling this particular expression using structural equivalence, आगे हम इसको पढ़ेंगे, इस concept को हम पढ़ेंगे, then it will say that internally X and Y belongs to actually integer data type. So that is why this expression is correct. X is equal to Y, right? Now the third point that comes under type expression is type constructor. What is it? It is a non-atomic data types. Non-atomic data types. What is the meaning of that? It is list of type expressions. Example, array. Suppose I have defined integer a 100. What is the meaning of that? What is the meaning of that? You have declared 100 integers with the name a. तो actually internally इसको कैसे define करेंगे? Integer कितने define करें? 100 and the representation of this is a. Similarly, you can define structure. Suppose I have defined a structure, a student, which is containing roll number, and then I have declared, say, marks, right? So this is also the type constructor where there are list of types stored. Fine. So Now let's take one example. How to write the type expression for function. So type expression for function. How to write the type expression for functions. Now, as we know that your function takes the parameter, right? So how to define it? Suppose there is a main program. In this program, I have integer a and say I have float b, right? I've called a function and passed the parameter a and b into it, right? And here is a function which is having integer m and say float n, right? Doing something in the function. This is the function definition. Now, what will be the type expression? So for this line where you are passing the parameter, your type expression will be t1 into t2. What is the meaning of that? Type expression of the parameter 1 a and type expression for the parameter 2. It is not a multiplication sign, it is a representation that you have passed two parameter, and first parameter is represented by the type expression t1 and the second parameter is represented by the type expression t2, right? Combining this is making t3, right? Which is a function. Now this particular equation t1 into t2 is equal to t3 will be matched by the formal parameters. Now what is the type expression for the formal parameters? It will be, suppose t1 cross t2 which is equal to t4. Now how your compiler will check whether these parameters a and b and these parameters m and n have the same type expression? It should be t3 is equal to t4. What is the meaning of that? Which means the a, which is the actual parameter, is similar to the m. That means m and a both are of integer type, and b, which is the actual parameter of float type, should be similar to the n, which is again of float type. So the expression of t1 and t2, which is represented by t3, representing actually the actual parameter types, should be similar to the t4, which is representing the expression types of the type expressions of the formal parameters, like, right? So this is the type expression while your parameter passing value, while you are passing the parameter as the actual parameter, and this is the type expression for the formal parameters when you are accepting the value from the actual parameters to the formal parameters. And internally your compiler will match whether t3 is equal to t4 or not. If both are equal, then only your function will get executed. Otherwise it will give you error that type mismatch. किस type की error मिलेगी आपको? Type mismatch. I hope you are able to understand this concept, right? Now let's take example. Your function is return type, which means my function is returning, suppose, integer value, that is r. So which means here my function is returning some value. Fine. So I'm returning something from this function, return, and suppose करो कोई value return कर रहे हैं हम यहाँ पे, right? What should be the expression? For this particular line, the expression will be this. What is the meaning of that? T1 is the first parameter, T2 is the second parameter, and when function will return, the value will be T3. The return value expression will be T3, which is equal to, suppose, T4. The whole function expression is this T1 cross T2, which is returning T3. So the function expression is T4. Now it should be matched with this function. What is the expression of this one? What will be the expression of this function? T1 cross T2, which is returning, say, T5, right? And this is represented by T6. So how type expression will be matched? the T4 should be equals to T6, which means what you are passing A and B, T1 and T2, what you are returning a value which is of type integer, right? The whole expression is represented by T4, and in the function, your first parameter is integer, that is T1. Your second parameter is float, that is T2, and you're returning integer, that is T5, and the whole expression is T6. So T4 is equal to T6. Now let's take example. By chance, I have written here character. Now, this expression will not be equal to this expression, because according to T4, it is returning integer, and according to T6, it is returning character. So your compiler will give error, that is type mismatch. I hope the concept of function type expression is clear, how the compiler handles this type of functions, right? Now let's see another concept that is called as type system. Type system. Now, first of all, what is type system? Type system of a language is a collection of rules for assigning type expression to various part of program. Right, so type system of a language is a collection of rules for assigning type expression to various part of program. Type system provides a concise formalization of the semantic rules. Second duty of the type system. Third, type system contains type checker. Now, what is type checker? It is an implementation of type system. It is an implementation of type system. So whatever we have learned till now, it is called as type system. So type system contains type checker, and type checker is what? It is an implementation of type system in the form of type expressions, right? So now let's discuss about the strong type language. There are two types of languages in the form of type checking. Type of languages, कौन सी languages की बात कर रहे हैं? Programming languages की बात कर रहे हैं. According to type system, एक तो आपकी होती हैं strongly typed languages, और दूसरी होती हैं आपकी weakly typed languages. So if your language is a strongly typed language, then obviously the type checking will be done at the static time, right? And generally in case of weakly typed language, the type checking can be static as well as it can be dynamic. Most of the time it is dynamic. So one of the example of a strongly typed language is Fortran. And there is one more language which is near to strongly typed language, that is Pascal. Otherwise, most of the languages, whether it is a C++, whether it is Java, whether it is Python, all these languages are weakly typed languages, which is a combination of static type checking as well as dynamic type checking. So if somebody asks you what are the features of a strongly typed language, then what will be your answer? So the question for the practice is, what is strongly typed languages? आपको इसके features define करना है. You have to define the features or some points which shows that this is the strongly typed language, right? In the next, and also with some examples where the static checking is done, or you will get the error if the language is a strongly typed language. Fine. So in the next lecture, we'll discuss about the type equivalence, which is of two types, name equivalence and structural equivalence. And also we'll talk about the type conversion. So as we have already discussed in the introduction, there are two types of type conversion, implicit and explicit. That is also called as supercast and subcast in Java. After that, we'll start a new topic. Fine. So we are ending our class here only. Let's meet in the next class.